In this video, I'm going to introduce a new switching feature called the VLAN trunking protocol. So, as I always like to start, why was this protocol created? What problem did it solve? Well, it's used to advertise VLAN attributes and minimize administrative overhead. What does that mean? Okay, so imagine for a moment a long string of switches. Let's say we have a campus that has 20 buildings. It's a really large company. Building 1 through building 20. Each building has, let's say, 5 switches in it. So we're talking about 100 switches total. Starting in building 1, switch, all the way to building 20, 100 switches. Now imagine they're all connected in a line, a string. And the way we've got our network designed is that, well, actually let's just do it like this so you can actually see it a little bit better. So here we have switch 1, switch 2. I'm certainly not going to draw 100 switches. And then over here we have our router. And this is the router that we're actually using as our default gateway. So regardless of what building people are in, this is going to be their default gateway to get to the outside world, to get to the internet. Okay, I just hired a new department. I've just hired a new section of my marketing team, and I decided that they're going to sit right here and right here, connected to switch 1 and switch 3. They're in different buildings, but part of the same campus. And I decided that I want them to have their own broadcast domain, which will be VLAN 7. So we know that in order to do this, a couple things have to happen. Number 1, on switch 1 and switch 3, I have to go in a global configuration mode and type VLAN 7 to create the VLAN. Number 2, I have to go into all these interfaces that are connecting to these hosts and type switch port access VLAN 7 to put them all into VLAN 7. Now we also know that if they're going to be talking to each other, which they're part of the same department, then I need to make at least these 2 links right here 802.1q trunks. But let's just say that's all I did. These guys still won't be able to talk to each other. Why? Well, if this guy here sends a frame and it goes across this trunk, it's going to have an 802.1q tag in it of VLAN 7. But what's switch 2 going to do? Did I create VLAN 7 in switch 2? I said, oh no, there's no people on that switch in this department. Well, if he doesn't know about VLAN 7, if a switch receives an Ethernet frame with a .1q tag, and the .1q tag indicates a VLAN ID that the switch has no knowledge of, he's going to drop that frame. He's going to say, I don't know that broadcast domain. I don't have it. So not only did I have to create VLAN 7 in switch 1 and switch 3, I also have to do it in switch 2. You say, oh, okay, no big deal. It'll take me 1 minute to log into switch 2, config T, VLAN 7. Done. Bam. Okay, great. Now these guys can talk to each other. But I want them to talk to the internet, right? I want them to be able to get to other networks. All right, so we know that I'm going to have to go on here and put some IP address on this interface that's in that network. So that can be the default gateway for them, so they can get to the internet. But once again, if all these switches, now remember, there was 100 switches. I've only drawn 5, but imagine 100 switches. If all these switches in the middle here don't have VLAN 7, once again, my hosts and marketing will not be able to reach their default gateway. So I have to create VLAN 7 on all the switches in the middle as well, so that that broadcast domain is reachable end to end. And this is what VTP was designed to solve. VTP is a feature that says, look, if I want to add VLANs or if I want to remove VLANs, I don't need to go onto each switch one by one and do that. How about I just go onto one switch, create my VLAN there, or delete an existing VLAN, and have that one switch tell all the other switches. Say, hey, here's a new VLAN, add this. Or hey, here's a VLAN that's deleted, get rid of it. That's the VLAN trunking protocol, a way of advertising VLAN attributes, like this is a new VLAN, or this is a deleted VLAN. Even a name. We know that when we create a VLAN and it takes us into config-VLAN mode, we can type a descriptive name like engineering or marketing. That way when we do the show VLAN command, the VLAN makes a little bit more sense. It's not just a number. Well, that name can also be propagated with VTP. So that's the idea behind it and the challenge it was designed to solve. This third bullet point answers the question, well, if you and I are a switch and I send you a VTP message saying, hey, here's a new set of VLANs, how do you know that my information is actually new? I mean, I could have stale old information and actually the VLANs that you know about are the correct VLANs and the ones I know about are the wrong VLANs. So how do you know when you get a message if it's actually a new message with new information that you really should take some action on, either adding the VLANs or deleting the VLANs? Well, one thing that VTP keeps track of is something called a revision number, a configuration revision number. All the switches running VTP have to be synchronized to the exact same configuration revision number. And the way it works is simply this. When I send you a VTP message telling you to do something, you just compare the revision number in my message with the revision number that you're currently synchronized to. If the one I send you is higher, that means you do what I tell you to do. That means my information is updated, is new. It doesn't matter if it's one higher. Let's say you're on revision number 10, and I send you a VTP update with configuration revision number 99. You'll say, okay, 10, 99, 99 is higher. I'm going to do what this says. I'm going to make sure my VLANs match this message right here. Now, if I sent you something which was lower, let's say I sent you a configuration revision number which was lower, you know what you would do? First of all, you would ignore it. You'd say, okay, I'm not going to do that. And then because you're nice and polite, you would actually send me a VTP message back saying, hey, Keith, you sent me 10. We're all locked onto 99. Here's 99. You should update your VLAN database. So VTP dynamically keeps track of these revision numbers to make sure that everybody is synchronized. The default is 0. So when you very first turn on VTP, it starts out as 0. And every time you add a VLAN, every time you delete a VLAN, it automatically bumps it up by 1. So it's not a number that you have to type in. It just increments every single time you make a change. Now keep in mind the name of this protocol, VLAN trunking protocol. That trunking is very important. This will only work across VLAN trunks. If two switches are connected with an access link, switch port mode access, VTP will not flow across that. We have to have a functional trunk. Now, it doesn't matter how you made the trunk. It doesn't matter if it's ISL, 802.1q, dynamic, static, doesn't matter, as long as there's a functional trunk between the switches. Now, when you enable VTP, and by the way, VTP is on by default, so the moment you turn on a trunk, VTP is running. Switches have 3 different VTP modes, which define how they send messages, if they're capable of originating a message, or if all they can do is receive one. So we're going to talk about those modes. The default VTP mode is VTP mode server. So every single switch you have, regardless of if it's big or little, cheap or expensive, is in VTP's server mode by default. And what this means is it will allow you to add VLANs and delete VLANs, and it will propagate that information via VTP information, VTP messages. Alternatively, you can configure, now you would have to manually do this, configure a switch as a VTP client. When a switch is a VTP client, it will not let you add or delete VLANs via the command line. You'll actually get an error message. Let me show you what that actually would look like. So I'll go onto the switch here, and the command is simply VTP mode, and then you select which of your modes you want. So I'm going to say client. Okay, and now if I try to create a VLAN, VLAN 88, I get that error message. Configuration is not allowed when the device is in client mode. So a VTP client can learn VLANs from servers, but he's not allowed to add or delete VLANs himself. Clients also will propagate messages. If a VTP message comes in, it will propagate it out. Which brings me to my third point. There's two primary things that have to match between switches in order for VTP to work. Number one, we've already talked about, a trunk. They have to have a functional trunk. Number two is that within the VTP message itself, there's a field called the VTP domain name. Now this is a name that you manually configure, and it can be whatever you want. You could say VTP domain Cisco, VTP domain Bob. It is case sensitive, and it has to match on the switches. So if you're using VTP domain Bob, and this guy's got a capital B and this guy has a little b, then they won't listen to each other's messages. So when a VTP message comes in, I inspect the domain name. It's got to be exactly the same as mine. Then if it's the same, the next thing I look at is if there's any password on it. We'll talk about that in just a minute. There can be optional authentication. You don't have to use it, but authentication is an option. So if there is something in there indicating authentication, I have to make sure that my password matches that message. And then thirdly, then I'll look at the revision number and I'll ask myself the question, is this lower, the same, or higher than what I have? If it's lower, I'll delete it, respond back with the higher one that I've got. If it's higher, I will update my revision number to match that, and I'll do whatever the message is telling me to do. If it's exactly the same as mine, I will just silently discard it, and I won't do anything else. So far we've talked about server and client modes. And the third mode is VTP transparent mode. So a VTP transparent switch is like a VTP server in that it will let you add and delete VLANs from the command line. A couple of big differences though. Number one, it does not originate VTP messages. In other words, if I go onto a VTP transparent switch and I add VLAN 7, he's not going to tell anybody else about that. If he has VLAN trunks, he will keep that information to himself. And if a VTP message comes in to him saying, hey, add VLAN 12, well, he'll look at the domain name to make sure it matches, and he'll look at the password if there is one to make sure it matches, but he could care less about the revision number because he's not going to do what that message tells him to do. He'll say, okay, it matches my domain, it matches my password, so now I can just pass it on. If it came in this trunk, I can just transparently pass it on downstream this trunk right here. But I'm not going to look at the body of that message because I'm transparent. I'm doing my own thing. Nobody tells me what to do when it comes to VLANs. So you might wonder, well, why would we use VTP transparent mode? There's several reasons. This thing about the revision number, how the higher number everybody's synchronized to, can actually is the primary downfall of VTP. And here's the reason why. Imagine for a moment that we have our building. Here's our building. And here on this floor is where our CEO happens to live. That's where his office is. And the switch that he's connected to, right there, that switch, that port is in VLAN, let's say, 2. So he's got his own VLAN, VLAN 2. And right now this switch is running VTP. And the revision number that everybody is synchronized to is, let's say, revision 11. Great. Now somebody comes along in one of our labs. Here's the lab right here. And they plug their own switch into the lab because, you know, they're practicing for their CCNA and they want to practice some switching commands. And this switch, you know, they're adding and deleting VLANs, they're doing all sorts of stuff. So right now this switch has a revision number of 20. And then they look up in the ceiling and they say, hey, there's some Ethernet jacks up there. There's some RJ45 jacks. I wonder what those do. Okay, well, let me take my switch and plug it into those ceiling jacks. And now they've just connected their lab switch into the corporate production network. And guess what happens? Their switch starts sending out VTP messages saying, hey, my revision number is 20. Problem is, this switch here does not have VLAN 2. So his VTP messages, when it's learned by this switch, he says, oh, you don't have VLAN 2? And you're higher than me? 20 is higher than 11? Okay, I'll delete VLAN 2. Question for you, review question. On an access port, so port, switch port mode access that's connected to a laptop or a PC or something, if this port believes it's in a VLAN that doesn't exist, switch port access VLAN 2, all of a sudden VLAN 2, boop, deleted from the VLAN database, it's gone. What happens to this port? If you said, oh, it goes back to the default VLAN, VLAN 1, you would be wrong. That's not what happens. The port stays in VLAN 2. He says, uh-oh, I'm in a broadcast domain that doesn't exist anymore. So I don't know what to do, so the port goes inactive. Inactive, which means no data in, no data out. It's not shut down, but it's basically useless. So now that port on that switch that's connected to my CEO's laptop suddenly has lost all network connectivity because the VLAN it was in has just been overwritten and deleted by that lab switch that had the higher revision number. And whoever plugged in that lab switch is going to be working at a fast food restaurant this afternoon. So that's the problem with VTP, is that a higher revision number can overwrite things, and that might not be the correct information. So some people say, well, I don't even want to risk that. I'd rather not use VTP at all. In earlier versions of software, if you did not want the benefits of VTP, your only option was to go into all your switches and set them to VTP transparent mode, because transparent switches do not generate messages. So you would not have to worry about that. So you just say VTP mode transparent, bam, you're done. Now you would essentially be turning off VTP. One thing you may have noticed, and I'll go back to it here, is in my switch, when I did VTP mode, one of my options was actually off. So in this version of software, I don't have to worry about that. I can just set VTP mode to off, and now VTP is definitely not running at all. Another reason you might need to use transparent mode is when you get to the CCNP level, if you go that direction in your studies and you start studying for the CCNP switch exam, and certainly at the CCIE level, there are certain advanced features that switches do that they can only do if they're in VTP transparent mode. That if they're in client or server, those particular features will not work. So that might be another reason why you need to be in VTP transparent mode. And optionally, like I mentioned, VTP does support authentication. You type in your password, you can see right here, VTP password, whatever you want. Once again, just like the VTP domain name, how it has to be the same on all the switches, and it is case sensitive. Same thing with the password. If you type a password, they all have to have it, and it all has to be exactly the same. And then what the switch will do is he'll take that password and put it into a formula which is called a hash. He basically performs a message digest hash. You don't have to know how that works. That's advanced cryptography, but basically it takes that password and creates a long string of letters and numbers. It hashes into this big, long, sort of random looking thing, and then that is what's put into the VTP message. So when I send my VTP message to you, you're actually going to get my hash of the password. But if you have the same password as me, your hash will end up being the exact same value. So even though you don't see my password, you'll know that we have the same thing because your big long string of hash value will be the same as what I sent to you. Okay, so here is the configuration commands. So step number one would be VTP mode server, that's the default. So if you want to be server, you don't have to type that. But if you want to be client or transparent, then you do have to type VTP mode. Step number two, type your VTP domain name. Make sure it's the same on all the switches and it is case sensitive. Step number three, if you want to, it's just optional, VTP password and then whatever your password is. And then technically, and make sure you got a trunk, got to have your VLAN trunks in place. And then you're done. You don't have to set the VTP version. That is just optional. At the CCNA level, all they expect you to know about is VTP versions 1 and 2. The really only difference about VTP version 2 is it added support for a really old technology that you probably won't ever see called token ring. Token ring was actually a competitor against Ethernet, but clearly Ethernet won because everybody's using Ethernet. But that's the only thing that primarily added in VTP version 2. VTP version 3, you learn about that at the CCNP level, so you don't have to worry about that. So let me do a quick demonstration of how this works. I'm going to use this topology right here. I've already got all 3 of these links set up as trunks, but right now all these switches only have VLAN 1. That's the only VLAN they've got. So what I'm going to do is I'm going to make this guy my VTP server, which he already is by default. I'm going to make this guy down here, switch 1, my VTP client, and I'm going to make this guy VTP transparent. And I'm going to set my domain, VTP domain, to, of course, INE. And then I'm going to create some VLANs in switch 3. And we're going to see how he propagates those VLANs to switch 1 and switch 2. Switch 1 will learn of those VLANs, so I'll have him propagate VLAN 2 and VLAN 3. Switch 2 will not. Switch 2, because he's running in transparent mode, will not learn of those VLANs. And so consequently, I will have to go onto switch 2 and manually create them on that switch. So you might want to take a screenshot of this real quickly if you haven't already done that, so that when I'm doing my configuration, you can follow along in which device I'm in. Okay, so I'm going to move this to the side here so I can reference it as I do my configuration. Okay, so here I am in switch 3 already. Now the primary command you're going to use for VTP verification to see what it's doing is show VTP status. Definitely want to memorize that command, show VTP status. And so you can see right now it's capable of running versions 1, 2, and 3, but it's currently running VTP version 1. I set this switch back to factory default before I started this video. So the factory default is that it does not have any domain name at all. It's empty. One also nice thing about VTP is that when it's like this, if a switch has no domain name and it forms a trunk with another switch, if it receives an incoming VTP message saying, hey, my VTP domain is Bob, this switch who has no domain name at all will actually take that name. He'll dynamically configure himself to have that name. But that only happens once. So now that he's Bob, if another VTP message came in that said, hey, my name is Sally, he'd say, you're not the same name as me, I'm going to ignore you. So on this switch here, I'm going to configure my VTP domain name, and we'll see how on my client, it actually learns of that domain name without me having to configure it at all. Okay, so right now he's client because I configured him earlier for that in our demonstration. So I'm going to say VTP mode server. Okay. Now before I configure the domain name, I'm going to go over to the other switches, switch 1 and switch 2, and configure them to be in the appropriate modes. So switch 1, we'll say VTP mode client. All right. And switch 2, VTP mode transparent. Okay. Now once again, just for verification, we're going to go into switch 1, show VTP status, and we see he does not have a domain name, but he's going to learn it from the server. Show interface trunk confirms that my trunking is working between my switches. No trunking, no VTP. So now let's go up to my server, which is switch 3. VTP domain INE. Now, as soon as I hit the enter key here, it might not take place immediately. VTP is actually kind of slow, but within, I would think, less than a minute, hopefully, we will actually see that as soon as I hit enter, switch 3 will send a VTP message downstream. We're not going to see it, but we should see on switch 1 that all of a sudden he has the domain name of INE, that he learned it. Not sure how long that will take, so let's find out. Okay, domain name changed. Let's go over now to switch 1 and see if he's learned that yet. And he did. So look how that was very, very fast. So right now he says he has 5 VLANs existing. Why does he have 5? Well, we can see here he's just got the default VLAN and then these 4 reserved VLANs, which aren't usable. So he's just got the 5 default VLANs. So show VTP status. We can now see that he's got the domain name of INE, and we can see here that he is a client. And right now the configuration revision is 0 because nobody has told him yet of any changes to the VLAN database. So now I'm going to go back to my server. Now before I do that, let's go to switch 2. Switch 2, who is my transparent switch. Did he also learn of the domain name? He did not, because he is transparent. He does have trunks. His trunks are working, but because he's transparent, he's not capable of learning anything from anyone. So let's just go ahead and configure the domain name on that guy. Okay. Now let's go back to switch number 1, and let's go ahead and add just one VLAN, VLAN 2. Oh, not switch 1. I need to, see, that's my client. Can't do it in the client. I have to go to switch 3, who is my server, VLAN 2. And let's give it a name, engineering. All right, let's see how long it takes to propagate that to my client, which is switch 1. Show VLAN. And there it is, VLAN 2, and it propagated the name. But if I go to my transparent switch, switch 2, he's not going to have it because he doesn't participate in any of that dynamic stuff. He doesn't have it. So let's just put it on him manually. And the last thing I'm going to demonstrate is VTP passwords. So I'm going to put a VTP password on switch 3. I am not going to put it on switch 1. And then I'll configure another VLAN on switch 3. And we'll see that switch 1 does not learn of it because there's a password mismatch. So switch 3, VTP password, let's do Cisco. Okay, let's go ahead and create a new VLAN, VLAN 3. We'll say the name of this is payroll. And we should not see that VLAN in the transparent switch, and we will not see it in the client. So let's go over to my client switch, show VLAN, and VLAN 3 is not there. And notice, there's no messages. We're not seeing any syslogs, any error messages. It's just silently discarding those VTP frames because it recognizes that there's a password mismatch. So let's go ahead and go in here and say VTP password Cisco, put the correct one on there. Now, I don't know if he's automatically going to learn of that or if we have to kickstart VTP again. Let's see. Yeah, he hasn't learned it. I've read somewhere that if you save your configuration, copy, run, start, that sort of kickstarts VTP, because VTP messages typically only go out about once every 5 minutes or so. You don't have to memorize that for the exam, but they don't go out very frequently. But I've read that if you save your configuration, that causes a VTP message to go out. Nope, not here. Let's save the configuration on the server. Write memory and copy, run, start. If you'll recall, do the exact same thing. So show VTP status. Right now he's at configuration revision 2 because I've made 2 changes. I added VLAN 2 and then I added VLAN 3. Let's see if my client is also on that same revision number. He is not. He's still at revision 1. Now, I could just sit here for 4 or 5 minutes and wait until VTP finally decides to send a periodic update, or, now you wouldn't want to do this next thing in a production network. I'm just going to tear down that trunk. I'm just going to shut it down. And then when I bring the trunk back up, then VTP should flow across it. No shut. Show interface trunk. 014 is up. Show VTP status. And now we are at configuration revision 2. And now I do show VLAN. We can see that VLAN 3 and the name is in there. And then the very last show command I want to show you is show VTP password. And you can see your VTP password. Notice in the output of show VTP status, you don't see it. Show VTP status does not show you what your password is. It shows you the MD5 digest that's used to hash the password, but it doesn't verify if I have a password, and if I do, what the name is. So you have to use the command show VTP password to actually see that.